Here we have a SAT math problem. Okay, let's go to the question. A consumer analyst believes that a new car will lose 18% of its value every year. After n years, the value of a new car that costs $20,000 is modeled by V equals to 20,000 times C to the nth power, where V is the value of the car after n years. To the nearest dollar, what is the value of the car 5 years after it was purchased? Here, the value of the car is modeled by an exponential function. It's given over here. Since the car will lose 18% of its value every year, so we have to consider this one as an exponential decay function. And also in this exponential function, this V represents a value of the car after n years. That is, this n represents a time period in years. Okay, to get the value of the car 5 years after it was purchased, we have to plug in 5 for n over here and get the value of this V. Okay, to evaluate the value of this V when n is equal to 5, we must be knowing the value of this constant C, so that we can get the value of this C when we plug in n is equal to 5. For that, we can consider the general form of an exponential decay function, that is y equals to a times 1 negative r to the power of t. Okay, here this y represents the value of a particular stuff after the time period t. So it may be in years or weeks or months, it depends on the situation given. And this a is the initial value of the stuff and this r is the rate of decay. So this is the exponential decay function. If it is an exponential growth function, instead of negative sign, we'll have positive sign over here. Anyways, let's compare this exponential decay function with the given situation. So instead of y, we have v, that is the value of the car after n years. We can write v over here. And a is the initial value of the car. Initial value of the car is nothing but the value of a new car, that is $20,000. We can plug in 20,000 for a over here. Let me write it. 1 negative. This R represents a rate of decay. So this 18% is the rate of decay because there is an information the new car will lose 18% of its value every year. So now we have to convert this rate of decay to decimal form. So for that we have to write 18% as a fraction, that is 18 over 100. So when I divide 18 by 100, I am getting 0.18. So this 0.18 is the value of R. Okay, instead of t in our problem we have n. This n is a time period in years. Okay, let me do some simplification over here. 20,000 times, when I subtract 0.18 from 1, I am getting 0.82 to the nth power. Okay, now I got the value of C at the place of C. Here I got 0.82. Okay, now what we have to do is we have to plug in 5 for n over here and get the value of V. That represents the value of the car 5 years after it was purchased. Okay, now let me plug in now 5 for n over here. Then I'm getting V equals to 20,000. Let me write the stuff over here times 0.82 to the fifth power. Okay, now let's evaluate the value of the 0.82 to the fifth power. Let me do it. So 20,000 times the value of this 0.82 to the fifth power is it's a bit long decimal, that is 0.3707398432. Okay, now we have to multiply these two values and we have to route it to the nearest integer because the question says to the nearest dollar. Nearest dollar means so the product has to be rounded to the nearest integer. When I multiply this 20,000 by this 0.3707398432, I am getting 7414.79. It keeps going. So when I want to round this value to the nearest integer, I have to consider the first digit to the right of the decimal point, that is 7. If it is 5 or greater than 5, then we have to add 1 to the digit at one's place. We have to ignore all the digits to round this one to the nearest integer. Since the first digit to the right of the decimal point is 7, which is greater than 5, let's add 1 to the digit at one's place. Then we get 7415. Now we can ignore all these digits. Okay, so the value of the car 5 years after it was purchased is $7,415.